Hi, today's notes are on 4.9, modeling polynomials. What modeling means is that it means to write an equation. So really what we're doing is writing equations of polynomials. Okay, so we're going to take a look, and today you're going to be given tables. And so what we're doing now is, instead of me giving you a set of points that have all the x-intercepts, and an extra point, or giving you a graph and having you write an equation where you can still see the x-intercepts, is now you're given a bunch of seemingly random points. And so then from there, you have to figure out what the pattern is changing by, and what it's changing by will help determine what type of function you have. So if you remember from chapter 1 and 2, it's been a while, so let's review. Your x's have to be constant. So I'm going to write change in x is constant. Okay, so the triangle means change in. Okay. And then the f of x's, or y values, you're looking for a change that is constant. Now, this is really important, and please trust me on this and don't take shortcuts. When I draw my arrow, I need to point in the direction that I want to go. Because what I get from students is often they're like, oh, it's a change of 3. Well, this time it's not just changing by 3, because if I do 4 and 3, that's actually 7. You need to say that you're subtracting by 3. Okay, and this is really important for you to keep track of. And then this one is adding by 3, right? Because my number is getting bigger. This one I add by 9. And I always put the plus, even if it's like adding, just to keep track of what it is and to identify, or to acknowledge the fact that I've added it. And then 13 to 28 is plus 15. Now, what if you're not so good at doing the math in your head and trying to figure out what the change is? Okay, so what you can do is you take your second number, subtract the first number. And the only thing you have to be really careful of is your signs. Okay, so right now they're all positive, so it seems nice and easy. So you take 1 minus 4, which is negative 3. 4 minus 1 is 3. 13 minus 4 is 9. And 28 minus 13 is 15. Now, that's not constant. Okay, so if it was constant, it would be linear. Let's now do this in a different color. Okay, so from negative 3 to positive 3, I'm going up. Now, what if I'm not so good with my signs? Let me just show you on the calculator how it would look. You would do, second number is 3. Minus is always there, and then because there's another negative 3, I have to do negative again. Okay, so I'm changing by positive 6, because it says it's changing by 6. And then I could go 9 minus 3, another positive 6, and then 15 minus 9 is another positive 6. Since the second difference is constant, and I'm going to set right, the second difference is always 6. So this function is quadratic. Okay, because x squared, that's my second difference. Excuse me, give me one moment. Okay, so let's take a moment to write in what each difference will give you. If the first difference, which is this first line of numbers, is constant, the polynomial is linear with a degree of 1, right? So it'll be x to the 1 power. If the second degree is constant, the polynomial is quadratic with a degree of 2. If the third difference is constant, the polynomial is cubic with a degree of 3. Fourth difference will be a degree of 4 and 5, right? So fourth is what we call quartic, like quarters, but quartic. And then fifth is quintic. Do you notice a pattern? So hopefully you see that, like, After this, it'd be a degree of 6th degree of polynomials, 7th, 8th. We don't need to know the names past this, okay? But if we have the nth difference, and n is any number, okay, then the degree is always n. Okay, so if you have the nth difference, like 10th difference, then the degree will be 10. If you had the 20th difference, the degree would be 20. Okay. So let's move on to 2 practice problems. We're going to use finite differences to determine the degree. Okay, so the first thing you need to do is determine the degree. And then you're going to use your graphing calculator to find the equation. So there's 2 parts to this one. So the first thing we want to do is figure out, using these tables, what are we changing by in each one. Okay, so if you wanted to pause the video here and just practice your changes, this would be a really good place to do some guided practice where you practice and you check what I've got. Okay. I know this seems very easy. Oftentimes I have students who never try to do this on their own because they're like, oh, I can obviously find what it changes by, but trust me, on tests it gets really complicated with the pluses and minuses especially. Okay, so try it yourself. So here you can see right away that it's not linear. Okay. So I can cross linear off my list. I'm going to cross it out because it's not constant. This one I add 3, add 4, add 5, add 6, add 7. So I know it's not quadratic because it's not constant there. And this last one, hopefully you see that it's just adding 1, adding 1, adding 1, right? So this is cubic. Okay, let's do the second one at the same time. Just practice your positives and negatives. This is pretty tricky, and the numbers get so big that you should definitely be using your graphing calculator to find this. Okay, so remember, it's always the second number minus the first number. Well, you know already that it's not linear, right? So I know that there's no way we're changing by the same thing because we're going up, 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 and then we're going down, and then up again. So maybe it's cubic, but we don't know. Okay? So let's see. I'm going to do, we'll put it right here, negative 37 minus negative 317. That's positive 280. 21 minus negative 37. Plus 58. Okay, 7 minus 21. So please try a few on your own. I can't stress it enough that like there's so many students who mess up on this problem, and it's supposed to be such a straightforward problem, but there's so many places for mistakes that you don't want your first mistake to be on the test. Okay, minus 47, minus 3, right? And then we will have minus 50, and then negative 289 minus negative 47. Okay, at this point I'm going to pause my video and just like take a moment to write it in. Can you take a moment and pause and try to fill this one out the rest yourself? Okay, so at this point we have our the two names of each polynomial function. We know the first one is cubic and the second one is quartic. Okay, take a moment, check your signs, make sure you've gotten close. Notice that if you make one tiny mistake, you'll never find this constant, right, change. So at this point, we're going to use our technology or graphing calculator to find the equation of each polynomial, which is just y equals. Now, we've done this before, but in case you forgot, the notes are on the back. Okay, so the first step, you have to determine what type of function it is using the differences or finite differences. That's what we just did. Step 2 is to input the values on your graphing calculator, and you're going to hit the stat button and then edit. And we're going to enter x's as L1 and y's as L2. Okay, so let's go back. let's do number 1. So please hit stat, which is right underneath delete, and notice it says here edit, so we're going to edit our lists. In order to delete, and I've written this on the back, you're going to go highlight, and don't hit delete, hit clear. Nothing happens until you hit enter. Okay, so go up, highlight, clear, and enter. And so you then have to put in all your x values, which is 1, 2, and I'm entering 3, enter, 4, enter, 5, enter, 6, enter, 7, enter. And then we go to L2 and we go 1, enter, 4, 10, 20, 35, 56, 84. And I do want to make sure that it's the same number of numbers I put in. Okay? So that's entering it. Now we need to calculate the regression, and so we're going to go to stat, calc, to make it calculate something. So let's go back. We're going to hit stat, calculate, and now we have all these options. We have linear if it's linear, quadratic if it's quadratic, and this one is cubic. So I'm going to scroll down, and some of your calculators are a little bit different at this point. Okay, so some of you guys will get like this weird list of things to put in. Just hit enter until you get something that looks like this. Okay. So notice now we have our A, B, and C values, and these are decimals. On the test, I wouldn't give you decimals like this. So, but for right now, since we do have decimals, we can just write it as it's a positive 0.17 x, and this is to the third power. Okay, do you see how A goes in there? Plus 0.5, oh, that's B, which goes next to x squared. And then C is plus 0.33, goes forever, x. Technically, we'd want this in like a fraction form, but we're okay with this right now because this is all we've got. Okay. Let's see. You should have, if we go down to diagnostic, you should have this on your calculator, and if you don't yet, on the day of the test, I can make sure you, well, no, you have to ask me before the day of the test, sorry. If you make sure that you have this, ooh, what happened? Let's see, D for diagnostic, sorry. There we go. So if you have this, what you should see is that you really want to have this r squared equal to 1, and if it equals to 1, then you are set and good to go. So the next thing you're going to do is input all of these and check it. I'm going to pause here and input my numbers myself, just so that you guys don't have to watch me, okay? But first, hit stat, go to edit, clear one list, and enter your numbers, okay? Ooh, and if you go to a different place, just go back and enter. Okay. Follow the steps on the back of your worksheet if you need. Hit stat, calc, and this time it's quartic, so we need to go past cubic and go down to quartic. What would happen if you got the wrong one is if I hit cubic again, do you guys see how r squared is not 1? That means I'm like 87, 88% accurate, but I'm not 100% accurate. So this is not the right one. So you need to go to calc and go down to quartic. And now, hopefully you see that r squared equals to 1. Now this does mean that technically you don't need to show all this work and you can just like guess your way through it, but please make sure you show your work here because I'm not going to accept calculator problems where you have none of this showing. However, if you get desperate and you make a mistake on the test, you can still get the answer without getting this part correct, right? And you just lose 1 point for that small tiny mistake. So let's take a moment and write in our answers. Y equals to, A is -3. And now we're going to the 4th power. You guys see that? And then minus 5x cubed plus 9x squared plus 3x minus 1. And that's our final answer. Okay. Don't forget the notes are on the back if you need reference.